So here we're talking about climate change, and most climate scientists would agree that global mean sea level is the best measurement we've got. When we look at the records of weather, and we talk about 1155 AD, what was the weather? How many storms? How about 2000 BC? How about 8000 BC? Oh, not a very complete record, I see. All right, well, anyway, let's talk about global mean sea level. Now, I can't do this vertically like the ocean's going up and down. I got to do it sideways. But this is 1-to-1. This is the actual scale, inch per inch, foot per foot, meter per meter. So we're talking from basically about 17,000 BC until the time of Christ, roughly, or a bit later. There's not much change. Not much change between the time of Christ and about 150 years ago, when the industrial age really was getting started. So we're talking here about the change from the most recent, not the last, but the most recent ice age, basically until today. So go for a little walk with me. So here's a staub I got right here, and we'll walk along. There's another staub over here. Let's go find that staub. That staub is right around here somewhere. There it is. There it is. All right, so this is 83 feet and 4 inches away, or 1,000 inches. So there's 1,000 inches away. We've got another staub here. And we'll go ahead and keep on getting up. There's actually a pattern of these things, which are all 1,000 inches away from one another. So that was 1,000. We're coming up on 2,000. Here's 2,000 inches, or whatever 2 times 83 feet and 4 inches is. And we'll keep on going. Let's just keep on going now. There's another one right over here. Oh, here it is. Here it is. Okay. So that's 3,000 inches. And up into the veritable woods. Let's see, here's another one. Here's 4,000 inches. Somewhere in the shadow. There it is. There's 4,000 inches. And let's just keep on going now. Now, truthfully, this final one is only 5,000 inches away, and it should be another 200 inches, or another 16 feet and 8 inches to the next one. But then we can see this is all natural, non-human influence effects, all having to do with the orbit of the Earth and its inclination. And we should be going further, but 5,200, you know, it's out there somewhere. And then, once again, we got to highlight how completely insignificant the change has been during the industrial age. And here I got my little buddy with me. Here's my little 10-inch stick. That represents sea level change due to CO2, due to the human effect, whatever it is, or maybe it's just another little jiggle on the natural slope, because most greenhouse gases are much more impactful than CO2, and it makes trees grow bigger and faster. And look at that stuff. Wait, there's dead stuff on the ground in the woods. And you know, the trees, they're sucking up CO2 and they're making lignin and all this other good stuff. But in a mature forest, the amount of stuff falling out and dying and rotting by fungi, by termites, silverfish, whatever else are in there, those things breathe in oxygen and they breathe out CO2. So, although people think that the mature forest is the lungs of the earth, it's not really. The only way we can have a forest removing CO2 from the atmosphere is by harvesting that wood and putting it into something that's not going to rot. Put it into a house, build furniture, make permanent stuff. Paper is not so permanent unless you're storing it forever in a cave or something. But you look in the woods, this is a mature forest here, and there's trees down everywhere. There's all the leaves on the ground. They're rotting away. They're not getting turned into coal or peat. That stuff just rots away. Look at that. Look at that. Stuff is just everywhere. Everywhere on the ground. Everywhere rotting away. Everywhere giving off its CO2 for the trees to reabsorb. So it's closed cycle. It's net zero. Mature forest is net zero. We got to harvest those trees if you want to take down CO2. And that's about it.